Hello all and welcome to this new video of Android security and exploitation by Pentesting Academy. My name is Aditya and I'm your course instructor for this entire training series. So in this particular video, we are going to have a look at the damn insecure and vulnerable application, which is also known as DIVA. Now, this is a vulnerable application created by Asim Jakhar of Paya2 and made in order to help you understand the different vulnerabilities in Android application. Now, a lot of these vulnerabilities is something which you have already gone through in the Android security for pen testers course by Security, right? So this might act as a learning experience or something where you can apply what you have already learned in the previous videos into another vulnerable application, right? And if you're completely new to Android security, it is also a good starting point to understand what different kind of security issues are present in Android applications. Now, apart from DIVA, there are a couple of other vulnerable apps which you can also go through. Some of them are like GoDroid, Insecure Bank, Interpreter's Learner, and so on, right? So before moving forward, this entire course is available at securityhub-training.com and pentestingacademy.com, right? So DIVA is an open source application and you can download the source code from this GitHub URL. Also, you can simply download the application binary from this shortened URL, right? So let me just go ahead and download the application as well as install it on my virtual device, right? So this is my Santaku VM. Let me simply SSH into it. I'll go to desktop, Pentest Academy. So in this case, I have already downloaded the zip file which contains the DIVA APK. So I'll simply extract it and I get the APK from here, right? Let me also make sure that my Genymotion device is connected, right? And now that my Genymotion device is connected, I can go ahead and install the DIVA APK. So this is how the application looks like, saying welcome to DIVA, and there are a couple of different exercises ranging from insecure logging to hard coding issues to insecure data storage and input validation and so on, right? So there are a bunch of exercises with which you can play with. So I'll just start with the first one, which is insecure logging, right? So insecure logging actually tells you what different ways in which Android application logs something sensitive to the Android logcat. Now if you have seen the videos, you must be knowing that Android maintains a centralized logcat which is accessible to all the applications on the device. So if an application developer wants to log something, maybe for debugging purposes, he can use the Android logcat and log the information over there, right? And you as a pen tester or a security researcher access that logcat over ADB or the Android debug bridge, or you can create another application which can read the logcat, right? So in this case, let's run this exercise and it's simply asking me to enter the credit card number, right? So I'll go ahead and enter the credit card number. Obviously this is not my real number. So I've entered the credit card number over here, and in the meanwhile I'll just check the logcat for this particular application. So I can grep for the process ID and I can do a logcat, adding grep of that particular process ID. So ADB shell PS grep-i diva, and I get the process ID of 1676. Now I can do a adb logcat and grep for 1676 and try to enter the credit card number. And if you see here, it simply says an error occurred, please try again later. But if you look in the logcat, you see the entire message as well as the credit card number. So in this case, the credit card number, which is a sensitive information, is being leaked through the logcat, right? And this is what the security vulnerability is. So whenever you build an application, you should ensure that you're not logging anything sensitive in the production build of the application. Or if you're using another libraries like ProGuard, that will actually take care of that as well, right? So that's all for this video, and if you have any feedback or queries, you can send me a mail at adi@atify.com, and you can check out the entire course at securitube-training.com and pentestingacademy.com. Thank you. Hello all, and welcome to this new video on Android security and exploitation by Pentester Academy. My name is Aditya and I'm your course instructor for this particular video series. So this course is being run on securitube-training.com as well as on pentestingacademy.com, right? So this video will cover the damn insecure and vulnerable application, which is a deliberately vulnerable app created for the Android platform. And in this particular video, we are going to have a look at the hard coding issues, right? So a lot of Android applications hard code something sensitive inside the source code, right? So if you somehow reverse the application, you would be able to see what kind of sensitive information is there inside the app source code, right? It might be something like a API key or a sensitive URL or crypto algorithm or anything for that sort, right? So the first step in order to analyze the hard coding issue is to reverse the Android application. And you can reverse it using different tools. You can either use jadx or dex2jar or any other tool for that matter, right? So in this particular video, I'll go ahead and use jadx in order to reverse the application. But before that, I'll just show you how the challenge looks like, right? This is the hard coding issue part 1. And it simply says find out what is the hard coded and where, and the hint is given developers sometime will hard code sensitive information for ease, and it asks to enter a vendor key, and if I try to enter something, it says access denied and a friendly message called see you in hell. So what I'll do now is I'll reverse the application using jadx, right? I'll just go to downloads, jadx, bin, and copy it from Pentester Academy, DIVA beta.apk to here, right? And if I look here, I have the jadx as well as the DIVA beta.apk, right? So let me go ahead and use jadx. So when you run jadx on any APK, it might show you a bunch of different errors, and most of the times you don't necessarily need to worry about it, right? So let's simply wait for the decompilation to complete. And looks like it got finished, even though with errors, but that is fine. So now we can go to diva beta, which was the name of the file, and here you'll see the Android manifest.xml as well as the different packages that were inside it. And since we know that the application package is jakhar.asim.diva, we can simply go to jakhar/asim/diva in order to check out the application source code, right? And if you do a ls-la over here, you will notice that there is an application, or sorry, there is an activity that is called hardcode activity.java. Now let's simply look at this activity, and it extends the app combat activity, has an onCreate method, and there's an access method which most probably will get activated or invoked when the button is clicked. So when I click this button, it will be calling this access method, and since I don't have the correct password, it says the access denied, see you in hell, right? And if you look at the line just above it, it compares whatever you have entered inside the text box to a string, which is the vendor secret key. So let's try to enter this particular string, and it says access granted, see you on the other side, right? And this is how you can identify the hard-coded security vulnerabilities. And in most of the application, you will find some or the other sensitive information being hard-coded inside the application code, right? So that was all for this short video, and if you have any feedback or queries, feel free to reach out to me at adi@atify.com, or check out the complete video course at security-training.com. Thanks. Hello all, and welcome to the Android Security and Exploitation training video series by Pentesting Academy. My name is Aditya, and in this particular video we are having a look at damn insecure and vulnerable application. So currently we're at the challenge 3, which is insecure data storage, the first part. Now this is a lot similar or something which you have already learned in the video 8 of Android Security for Pentesters course by Security Training, right? So if we have a look at the application, the insecure data storage part 1, it tells us to find out where the credentials are being stored and the vulnerable code, right? So, and it simply asks to enter the third party service username and the password, right? So let's try to enter something over here. We just simply write up Atify and Security Training and go ahead and save it, right? Now there are a couple of places where an application can store the data, and one of them being shared preferences. Now, even though shared preferences are not recommended to be used for sensitive information, a lot of developers end up using storing any kind of sensitive information in the shared preferences. And if you're already familiar with ADB or the Android debug bridge, you can find out the shared preferences at this location, which is /data/data, the package name and the shared prefs. So let's go ahead and maybe first have a look at the file responsible for storing the data. So I guess this should be the insecure data storage 1. So let's look at it, and if you look here in the save credentials code block, it simply uses the preference manager and get default shared preferences and stores the username and password, right? And prints out that third party credentials have been saved successfully. So this is an indication that shared preferences are being used to store the data. Now let's go ahead and analyze the file system and look at the shared preferences. So we'll do a ADB shell and go to /data/data jakhar.asim and go to the shared prefs, right? And if you look over here, there is a preferences.xml which is stored over here, and if you simply cat this file, you'll see that the username and password, which is Atify and Security Training, which is exact same thing which we saved over here, right? So this is how an application stores data in the shared preferences, and this is how you can access it. So that is all for this short video, and in the upcoming videos we'll have a look at the other ways of insecure data storage and so on. So thanks for watching the video, and if you have any feedback or queries, feel free to reach out to me on Twitter, which is ADI1391, or you can send me a mail at adi@atify.com. Thank you. Hello all, and welcome to the new video of Android Security and Exploitation by Pentesting Academy. My name is Aditya, and I'm your course instructor for this entire training series. So this course is being run on security-training.com as well as pentestingacademy.com. So this video is about the insecure data storage which is present in the DIVA application, right? So in the previous video we had a look at how an Android application stored the information in something known as a shared preferences. So if we come to this particular challenge, the challenge 2 of insecure data storage, we'll notice that it's a similar screen where it's asking to enter a third party username and password, and it's storing it somewhere in the file system, right? Sorry. So let me just go ahead and enter something. So let's see, test user, password 123, and I will just save it. Let me go to ADB shell, go to the data jaka.asim.diva and look over here. So now an application can store something in shared preferences or the databases as well, right? And apart from that, an application can also store something in the external storage, right? So let's simply look at databases and see if we find something. So in databases, we have the diva nodes.db and the IDS2. So if we analyze the diva nodes.db first using SQLite 3, we look at the different tables. There's a table called nodes, and if we look at the nodes table, it has all this bunch of information which is not useful for us. So let's simply exit this and analyze the other database, which is the IDS2. So SQLite 3, IDS2, and if we look at dot tables, there's a my user table over here. So if we do a select star from my user, we get the test user and password 123, right, which is what we saved over here. Right. So SQLite databases are another way in which an Android application can store something sensitive, and you'll often find a lot of information storing the auth token, cookies, and these kind of other information in the SQLite databases. Right. So that is all for this short video, and it should be actually the databases and the database over here. I'll create it with IDS2. Right. So that's all for this video. I hope you liked the video. If you have any feedback or queries, feel free to reach out to me at adi@atify.com. Thanks. Hello all, and welcome to the new video on Android Security and Exploitation by Pentesting Academy. In this video, we are going to have a look at the insecure data storage part 3. So this entire particular video is going to be dedicated for damn insecure and vulnerable application, but you can also take the concepts and apply it to any real world application as well, right? So this course is being run on pentestingacademy.com as well as security-training.com, right? So in the insecure data storage 3, if we look at the application, it is the same as the last two parts, and it again asks for the third party service username and the third party service password, right? So if you go ahead and enter username and password, let's say Aditya, and password as Aditya123, right? And we simply go ahead and save it, right? Now where this data gets stored, we can figure out that by having a look at the source code, right? So let's have a look at the source code in DIVA beta, Jacker, Asim, DIVA, and the insecure data storage 3 activity.java. So if you look over here, it says that there's a method called save credentials which takes the input from the text boxes, which are most probably these two text boxes, and creates a temporary file called uinfo and takes everything from these two fields and saves it inside this particular file. Right. And once the file is saved, it simply says the third party credentials saved successfully. Now it saves the file in the data directory, right? And we know that the data directory is the location /data/data package name, right? So let's go ahead and look at the data directory. So we'll go to /data/data jacker.asim.diva and we'll just ls over here. So now if you look over here, there's a file called uinfo-122 number and a tmp. And if you simply cat this file, it tells you the username and password, which is the username and password which you saved over here, right? So this is one of the ways in which some of the applications insecurely store data. So that is all for this short video, and if you have any feedback or queries, feel free to reach out to me at adi@atify.com, or you can tweet out to me at adi1391. Do check out the course at securitube-training.com and pentestingacademy.com. Thank you. Hello all, and welcome to the new video of Android Security and Exploitation by Pentester Academy. My name is Aditya Gupta and I'm your course instructor for this training series. So this course is being run on pentestingacademy.com as well as securitube-training.com. Right. So in this particular video, we are going to have a look at the insecure data storage of the DAM's insecure and vulnerable application, also known as DIVA. Right. So as we have previously discussed, an Android application can store data in a couple of ways. So either it can store in the shared preferences, or it can store in databases, or it can store as a raw file, or maybe it can also store on the external storage, which is usually the SD card, right? So if we come to the part 4 of the insecure data storage, it is a similar screen asking us to enter the username and password. So let's say if we enter something, maybe username 1 and password 23, and we save this particular information. So now if you look over here, there is no additional file which is created, and if you look at the shared preferences, it is not over here and also not in the databases, right? So the other possibility is it could be in the external storage. Now in order to check the external storage, you need to go to /mnt/SD card, and if you do an ls over here, you don't see anything like a new file or a new created file over here, right? But if you do a ls-la, you see something as a .uinfo.txt which have been recently created, right? So a lot of application developers, what they think is storing something in the SD card might not be secure, but if they store it with a dot in the start, making it a hidden file, that might make the file secure, right? Which is not the case, right? So anyone can simply do a ls-la and get to know the hidden file. And if you simply do a cat.uinfo.txt, it's the username 1 and password 23, which is what we entered over here, right? And if we want to look at the source code, we can check out insecure storage part 4, and we see that it is taking the location of the external storage directory and creating a file called .uinfo.txt. So either you can reverse engineer the application, figure out how it is storing the data, or you can try a hit and trial approach, right? So that is all for this particular video, and if you have any questions or queries, feel free to reach out to me at Twitter ADI1391 or over email adi@adify.com. And you can also check out the certifications and the training course at securitube-training.com and pentestingacademy.com. See you in the next video. Hello all, and welcome to the new video of Android Security and Exploitation by Pentesting Academy. My name is Aditya and I'm your course instructor for this entire training series. So this course is being run on pentestingacademy.com, and you can also check out the certifications at securitube-training.com. So this particular video is about the damn insecure and vulnerable application, also known as DIVA. And in this particular video, we'll have a look at one of the input validation issues. Now, input validation can happen in multiple ways. And one of the ways is if the application takes the user input and passes it inside a SQL query and executes the SQL query as it is, leading to flaws such as SQL injection. Now, this is a classical example of authentication bypass using SQL injection, right? So, let's have a look at the exercise, which is input validation part 1. So, in this exercise, the objective is to try to access all the user data without knowing any username. And it says that there are 3 different users by default, and the task is to output data of all the 3 different users. Now, if I don't know what the username is, I can try something as test, where it says user test not found, right? So in order to look more deeper inside this vulnerability, let's have a look at the source code. So this is the input validation 1, which is somewhere over here, or the SQL injection activity.java, right? So let's open it up, and if you look here, it takes the search text, which is the text that you enter over here, puts it inside a variable called srch text and passes it inside a SQL query as select star from SQLi user, where username equals to whatever you have entered, right? Now, in these kind of cases, what you can do is pass in a malicious string such as 1 or 1 equals to 1, making sure that this particular string in SQL will always be true. And this is because we're using a conditional operator or over here. So if let's say the SQL query is this one, select star from SQLi user, where user equals to this particular value. Let's also copy the closing tags, which is this one. And this is what the application is essentially doing, right? And it places the user text, whatever we have entered, right? Now, if we enter something like an admin, it tries to select the user admin from the table, right? And if the admin does not exist, it simply returns a false. But if we try something like this, a string 1 or 1 equals to 1, in place of the user, the string becomes select star from SQL user, where user equals to either 1 or the other condition is if 1 equals to 1. And since 1 equals to 1 is always going to be true, this entire statement is going to return true and all the user's information will be dumped, right? So let's try this over here. 1 or 1 equals to 1, and we add everything after this as a comment, so the two hyphens, and we click on search and we see the entire information of all the users, right? And this is how a SQL injection in an Android application takes place. Now also another thing to note is this particular vulnerability will be mostly applicable in applications which are doing something locally, right? Because it's taking the user input and passing it inside the local SQLite query and executing it, right? So that's all for this short video. I hope you liked the video, and if you have any feedback or queries, feel free to reach out to me at ADI1391 on Twitter, or you can send out a mail to me at adi@atify.com. Check out the certifications at securitube-training.com, and that's all. Thank you. Hello all, and welcome to the Android Security and Exploitation Training Series by Pentesting Academy. My name is Aditya and I'm your course instructor for this entire training series. So this course is being run on pentestingacademy.com as well as securitube-training.com is where you get your certifications. So this particular video is about the damn insecure and vulnerable application, or DIVA, and we are checking out the input validation issues part 2, right? So in the previous input validation issue, it was a classical case of a SQL injection vulnerability. Now in this case, if you look at the application for the input validation issues part 2, it asks you to enter a URL, and that particular URL content will be displayed below, right? So let's say if I enter www.atify.com, it tries to open the atify.com website, but it isn't able to, right? Because there's a proxy set on the device or for some other reason, right? Now at the same time, you might wonder that since it is able to open the websites using this embedded web view, will it be able to access the internal files using the file protocol, right? So if you look at the ADB shell and let's say /data/data jakharasim diva, right? And we notice we have a file over here. So let's try to read this file from this particular browser or an embedded browser. So we'll do file /data/data jakhar.asim.diva / the file name, right? We'll just remove the space from here and everything looks well and good. And if you try to click on view, it actually showed us the contents for this particular file, right? So Aditya123 is stored over here, and this is what we get over here, right? Now this is a really critical security issue because an attacker can use this particular functionality to read the internal files from the file system, right? So maybe it could be simple information as the temporary files, or it could be something as sensitive as a cookie stored in one of the databases, right? So this is what you can do with these kind of security issues with the input validation flaw. And also you might wonder that since you are able to read the local data storage, will you also be able to read the external storage? Now, since the application has permissions to read the external data storage, let's try to read a file stored on the SD card. And for this example, let's try to simply read the test.txt, which contains a string called secret. So let me just read this. and try to read the MNTSD card test.txt, which is a file stored on the external data, and it shows us the contents of this particular file, right? So this is one of the examples of how an input validation issue could lead to the data being stolen or the sensitive data being compromised. And that is all for this particular video. So you might want to experiment with what else you can do with the input validation issue as well, right? So thanks for watching the video, and if you have any feedback or queries, feel free to reach out to me at ADI1391, or you can email me at adi@adify.com. See you in the next video. Hello all, and welcome to the new video of Android Security and Exploitation by Pentesting Academy. My name is Aditya, and I'm your course instructor for this entire training series. So in this video, we are going to have a look at the access control issues of the damn insecure and vulnerable application. So access control issues simply means that the application is not able to authorize or correctly validate the access of a particular user. So someone with insufficient authorization or insufficient access can also view the protected content with this vulnerability, right? So if we have a look at the application, which is the access control issues 1, it says you are able to access the API credentials when you click the button. Now try to access the API credentials from outside the application. So if we click on this button, we are able to access the API credentials, and that's perfectly working fine. But we want to access the API from outside the application, and we know that we can use something like an AM or activity manager, which we have already seen in the Android for Pentesters course, and use it to invoke a particular activity, or maybe to launch a browser, or maybe to invoke an intent filter, and so on, right? So first of all, let's go and have a look at the Android manifest for this application. So if you look at the Android manifest and search for access, yeah. So this is the access control 1 activity, and we have the API creds activity, which has the intent filter of view creds. Now we have already discussed what an intent filter is in the earlier course videos, right? So all we want to do is invoke the API credentials activity by simply using this particular intent filter. So let's simply go ahead and copy this, and we'll use ADB shell am -a and the intent filter. Let's see if it works. And if you click on view creds, it doesn't work. So ADB shell am -a Jaka scene DIVA action view creds, right? Oh, so looks like I missed a start over here. So am start -a. And now if you see, we have access to the API credentials from outside the application, and this is how you can use an intent filter with the activity manager or AM. So that's all for this short video. In the upcoming videos, we are going to have a look at several other access control issues and a couple more issues, right? So if you have any feedback or queries, feel free to reach out to me at adi@adify.com, and do check out the certification at securitube-training.com. See you in the next video. Hello all, and welcome to the Android Security and Exploitation training series by Pentesting Academy. I am Aditya, and I'm your course instructor for this entire training series. So you can check out the certifications at securitube-training.com, and you can also view the entire course at pentestingacademy.com. Now, in the previous video, we had a look at the access control issues, and we were able to invoke the activity containing the API and the key using the intent filter and the activity manager, right? So in this particular example or this particular issue, which is the access control issues part 2, it asks for whether you want to view the Twitter API credentials, and if you click on register now and click over here, it asks for a PIN, right? And it asks you to register at a website and log in with that particular PIN, right? So the objective is you're able to access the third-party app API credentials after you have registered, right? Now you can register online and the vendor gives you a PIN, but what you want to do is access the API credentials from outside the app without knowing the PIN, right? And this is quite similar to what we did in the previous video. So let's try the same example, let's try the same method for this particular example as well. So this particular one is access control issues part 2, and if we look at the Android manifest.xml, and we have the access control 1 activity and the access control 2 activity, where the intent filter name is viewcreds2 instead of simply viewcreds. So let's try to use this. So ADB shell aim start -a Jacquard assume diva dot action dot viewcreds2, and let's see what happens with the application. Let me go to the home screen and then try this out. And now as you see, it brings me to a enter pin screen rather than showing me the actual API key. So there is a kind of protection here which you will need to bypass, right? So if you look at the source code for this particular exercise, you'll notice that it checks for another parameter which is called checkpin or chk_pin, and if it is true, it asks you to register at a particular website and log in with that pin. But if the checkpin is set to false, it tells you the API key and the password. So all we need to do is invoke this intent filter along with an extra parameter. So you can do it with either aim, which we did earlier, and add in an extra parameter to it, or you can also use browser in this case in order to launch an intent filter as well as pass in additional arguments to it. So you can know more about browser in the training videos. So there we have discussed in detail on what browser is, how do you start it, how do we do a basic exploitation, even scripting and so on. So you can check out securitube-training.com in order to check out all those videos. So we'll start browser, and I check out the activity names for this particular package, jacquard.assume.diva. Now if you notice, there are 3 different activities. One is the main activity, and then you have the API creds activity, which was the previous exercise, and now you have the API creds 2 activity. So what we'll do over here is we'll start the API creds 2 activity along with an extra checkpin boolean set to false. Since in the code you can check that the checkpin variable is actually a boolean, so you can set it to false and launch the API creds 2 activity. So let's do run app.activity.start --component, and let's simply copy this one along with the package name, which is jacquard.assume.diva, and passing in extra data, which is checkpin. So extra boolean checkpin set to false, and let's see if this works or not. Before this, let me just go back, quit the application, then launch this. this didn't work. So let's see where we went wrong. Run activity start. So sorry about the short interruption. So the CHK pin that we are actually trying is a string located inside the strings.xml. And if you look at the source code, which is there at this GitHub URL, you can go inside the app and navigate to source, main, resources, then values. And here you will find the strings.xml. And if you open up the strings.xml and simply scroll down, or let's say maybe better, okay, so here it is. So if you look over here, there's a string with the tag of chk pin, and the actual string is check underscore pin. So the check underscore pin is what we need to use inside our statement. So let's try to launch the activity. So app.activity.start component Jacarasim Diva, which is the package name, and then the activity name is API creates to activity, passing in an extra boolean of check pin false. And if you look over here, we have the API key as well as the username and password. So this is how you use Drozer in order to start an activity along with passing extra variables to it. So that's all for this video. If you have any feedback or queries, reach out to me at adi@atify.com. And if you want to check out the complete course videos, you can go to securitytube-training.com, or you can get a subscription at pentesteracademy.com. See you in the next video. Hello all, and welcome to the Android Security and Exploitation training course by Pentester Academy. I am Aditya, and I am your course instructor for this entire training series. So in the previous video, we had a look at some of the access control issues. In this video, we are going to have a look at another type of access control issue, which is related to content provider. Now, in the Android Security for Pen Testers course, we have already discussed a lot of different content provider based vulnerabilities and exploitation using Drozer. And this particular vulnerability is the exact same thing of what we did in the Catch Notes application in the Android Security for Pen Testers course. So I highly recommend you to go watch those videos and come back and try out this exercise. So let me open the DIVA application and go to the access control issues part 3. Right. So the objective of this particular exercise is to set up a pin and then create several private nodes and try to access the private node from outside the application without knowing the pin. Right. So let's set up a pin over here, and for this example we'll set it up as 1234. So pin created successfully. Private nodes are now protected by a pin. And now I'll go to private nodes, type in 1234, and these are the different nodes which are there in the private storage. Right. So the first thing which we have to do is launch a browser in order to find out the different content providers. So also we have discussed a lot of browser related content in the past, so feel free to check out those videos as well. So I'll start a browser here and run a app.provider.findURI and put in the package name, which is jaka.asim.diva. So this particular command actually finds all the different content providers stored in the application. And if you notice, this is the content provider which is related to nodes. So it's Jaka.asim diva provider nodes provider / nodes. And all we need to do in order to access it is app.provider.query hyphen URI and the content URI. And just for better formatting, we'll add a hyphen vertical as well. There's no hyphen URI in this one. And if you notice over here, we get the entire data which is stored in the private node section. And we got all of this without even asking for a PIN or without even entering a PIN. Now you can try out the same thing using ADB shell content query hyphen URI and passing in the content URI. So instead of browser, if you want to do it with ADB shell, you can do it as well. Shell content query and the content URI, and you see all the data over here, right? So even though it is protected in the application, the content provider in itself is vulnerable, and we can confirm it by just looking at the Android manifest. So if we look at the Android manifest and search for provider, so if you notice over here, it is exported equals to true, and that is the reason why this is vulnerable. So in order to ensure that your content providers are secure, you can either set it to false or you can add the required permission for this particular content provider. So that's all for this short video, and if you have any feedback or queries, I'd be more happy to hear it. You can reach out to me at adi@1391, or you can over email at adi@artify.com. You can check out the certification at securitube-training.com or the subscription model with pentestingacademy.com. See you in the next video. Hello all, and welcome to the new video of Android Security and Exploitation by Pentesting Academy. I am Aditya and I'm your course instructor for this entire training series. So if you're watching the video, you can go check out the certifications at securitube-training.com, and you can also subscribe to the videos at pentestingacademy.com. So in this particular video, we are going to have a look at the damn insecure and vulnerable application, also known as DIVA, and we'll have a look at the hard coding issues, the second part. So in the previous hard coding issues, if you remember, we had a look at the application source code and we were able to figure out the vendor secret key, right? But if you look at the hard coding issue in this case, you will notice that the JNI is used to perform validation. And what do I mean by this is, if you open up the source code, Jaka Rasim DIVA, and go inside the hardcode 2 activity, you'll notice that the djni.access is actually getting a text from somewhere using the JNI, and it is checking it whether it is valid or not, right? Now, the way in which you can check it is by doing an ADB shell, going inside the application directory and looking at the lib folder. So if you notice, we have a libdiva.jni.so over here, and all you need to do is pull out that SO file and analyze it using objdump or readelf or any other disassembler for that matter, right? So we just exit this and do a ADB pull, and the location I'll use is /data jaka.asim.diva/lib/libdiva.jni.so, right? And now once I have the this particular file, which is libdiva.jni.so, I can go ahead and analyze it. And one of the ways to analyze it is by simply running strings on this particular SO files. So a lot of times the vendor or the manufacturer of the application actually hard code the keys inside the SO files. So if you run a strings, you'll be able to see all the different constants or strings inside the SO file. So you see a lot of different sections like the data, the BSS, and you also see some weird looking characters or strings such as this one or the dot 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 string, right? And this could possibly be the secret key, right? Now another way to check is whether the vendor would have declared these particular key inside the RO data section. And the RO data section is simply a segment which stores the constant data in a binary, right? So if you want to look deeper inside any binary or any SO file for that matter, you can check out the ELF structured at this particular URL. So once you go through this URL, you'll be able to figure out the different sections that are there in a binary and what does exactly RO data means, right? But for now, we'll simply use obj dump along with showing the full content using -s and printing out the section RO data specified by -j. So let's try this out. So we'll use obj dump in order to extract the RO data section. So let's go ahead and use it. Let's specify, and if you notice, it has printed out the contents of the RO data section. And in this case, it simply is this entire string, right? So this might be one of the strings, and this could be another string, right? So let's go ahead and try out this on the access control issues, or in fact the hard coding issues part 2. So let me just go ahead and copy this and paste it over here. And if you click on access, it says access granted, see you on the other side. So this was indeed the key which the hard coding issues challenge was looking for. Now another way to get the same information is using the readelf utility. So you can do a readelf -x dot RO data and then the SO file name, and it will print out the same RO data section. And for further information, you can also look for the source code for this particular exercise, which is in the DIVA Android App src main JNI. And if you look at diva jni.c, you can see that vendor key is one of the constants that is defined, and this is the value. And later on, the vendor key is the key that it is comparing it against, right? So this was the hard coding issue part 2, and this pretty much is everything about DIVA. Now there is another exercise which is the part 13, input validation issues part 3, right? And I highly recommend you to go ahead and try it out as a challenge, right? So you can check out the complete training at securitube-training.net, and you can check out the subscription videos at pentestingacademy.com. And feel free to reach out to me at adi@atify.com or tweet it to me at adi1391. So hope you enjoyed the video, and looking forward to see you in the other course videos.